Anyway, hello. My name is Maarten Dirkse, and my talk is called Non-Prod Considered Harmful. So I submitted this talk to Blips, and my boss from Skyworks called me at one point. He's like, I think the subject of your talk is fairly interesting, but the title kind of sucks. Can we change it to something more catchy? I was like, the title sucks. Wait, do you not get the reference? And then I realized I'm old and I need to explain some things to the younger generation. Boss is 2 years younger than me, so it's not that bad. But raise your hand if you do not get the reference. Okay. So, a bit of Dutch computer history for you here. You're not supposed to be able to read this, don't worry. So this is a reference to something, to a letter to the editor of the proceedings of the ACM, the American Computer, not entirely sure what M stands for, but a magazine about computers that was published and was known as the leading scientific journal about computing in the 60s, 70s, 80s, and some say still is, by a guy called Edsger Dijkstra, who is a Dutch computer scientist and one of the founders of the field of programming, you may say. He wrote a letter to the editor about the fact that everyone and their mother was suddenly using go-to statements in their programs, and that was actually really a bad idea. You were supposed to use proper branching and stuff. And I chose this title because I think that non-production environments are like go-to statements were in the 60s. Everyone's using them, they're a crutch, they seem like a good idea, but they're actually a really bad idea. So now you understand the reference.
He said everything and knew their mother, and my mother wasn't even born yet.
Well, okay. So the intro, including tortured historical metaphors. Non-prod is a costly hoax. I'll explain how that works. How to have just production and nothing else. And finally, some frequently asked questions that have come up over the course of me talking about this to various people. So this is me. In this picture, I've just scaled a mountain at considerable expense and effort, and found out that at the top of the mountain it's really foggy and I can't see anything, which is why I look like this. I work at Skyworks. I live in Leiden with my wife, 2 daughters, 3 cats. I studied history before I got into computers, and I'm a crazy cat nerd. I've been in software, CI, and cloud engineering since about 2007. And if you want to follow me on social media, you can do that there. I'll repeat this at the end when you've decided whether I'm actually interesting or not. Before we, this talk is about production environments and why you shouldn't use anything else, but I want to start with this. And this is the part where the fact that I studied history also becomes your problem. This is the Sasebo Temple, and I was very fortunate last summer to be able to visit Japan, and we decided, this wasn't on the itinerary when we went there originally, but we were in a place called Aizu Wakamatsu, which is where this temple is at. This is a temple built in 1796, and it's a Buddhist temple. And it's very special because it has a unique double helix internal structure, which means you can walk up and walk back down the temple without ever meeting anyone going the other way. It contains 33 statues dedicated to Kannon, which is the Japanese name for the Buddhist. I'm not an expert on Buddhism at all. So Bodhisattva is someone who has achieved enlightenment of compassion. And it was built, it was thought up and built by this 18th century Japanese monk called Ikudo. And now you're all wondering to yourself, what the hell does this have to do with anything I came here for today? Well, it condenses, so what this does is it condenses a pilgrimage that takes months into minutes. And what do I mean by that? Well, those 33 statues and the 33 shrines inside that temple, they also exist in other places in Japan. And there is a traditional pilgrimage that's been around for centuries that that basically goes on, that is in the surroundings of Osaka and a bit in Kyoto. And there are 33 individual shrines where you have to, well, if you're a proper pilgrim, you walk there, and you walk to one after the other. And in total, as you can see here, it was 30, as it turns out, Google Maps doesn't do 33 separate destinations in one itinerary. So if you combine it and you walk around 10 hours per day, it'll take you about 23 days in total. And this temple was built by Ikudo because Ikudo thought, well, you know, I want to pay my respects to this deity. I want to achieve enlightenment, but 33 or 24 days of walking kind of sounds like a lot. And probably in 18th century Japan, it was even more because the roads weren't that good. How about we do the 33 things that take weeks to visit and just put them in one building? And that's what he did. So he condensed the entire pilgrimage that took, over 2 weeks of walking into one building. And so you go up and you go down and you pass the 33 statues, you can pay your respects, and you do the whole thing that would otherwise take you weeks in minutes. Pretty efficient, right? I mean, this was like some next level thinking, and that's why I like to call Ikudo the 10x monk, right? Really, really great, a great way to approach. They say the journey is the destination, but in Ikudo's case, it's like, no. Forget the journey. Just, give me the spiritual advantages of praying to these gods. And what does this have to do with why you're here? Well, you can think of the trajectory that your code takes from development to the test environment, to the acceptance environment, to production as a kind of pilgrimage, where along the way, these are all stations that you pass, development, acceptance, test, production. Along the way, you pay your respects to certain gods, the god of metrics or the god of observability, the god of revenue, which is in production. And you have to pray to them before you can move to the next stage. And I want you guys to think like a modern day Ikudo, to think, why do we have to pass all these stations on our way to production? Why not just condense them all into one single place where you do everything? So what do you do in dev, right? You do deployment. You have to honor the deployment gods. You have to honor the test gods. You do the same thing in tests. Then in acceptance, you do those plus the QA gods, plus the monitoring. And then finally in production, you also do deployment, and then you do monitoring, and finally you get to the revenue, right? What if we just did all of that in production, right? Software delivery enlightenment. Deployment, testing, QA, monitoring, revenue, everything. Just do it in production. Skip all the other environments, just do everything in production. Now, you might be thinking to yourself, that sounds, well, it might not sound nice, it might sound terrifying, but it might also sound nice, but is that possible? And I think it is, and I will give you an example, and not just any example. The first example, if you will. So can someone tell me what this is a picture of? No, close, but not quite.
These are programmers.
I'm sorry?
These programmers are they used?
These, yes, that's true. These are programmers, but no, I'm talking about the machine, not the. Yes, it's the ENIAC. So for those of you who don't know what the ENIAC is, it was built in 1945. It was actually built for the World War II effort, but finished only after the war. It's recognized as the first general purpose computer, right? So you had the Enigma machine, and you had a bunch of other forerunners, but the ENIAC is actually recognized as the first general purpose computer. Construction cost $7 million in today's money and took almost 3 years. And there was no test environment, right? They couldn't just spin up another one just to try some stuff out, right? Hard to do because it was going to take another 3 years. So no test environment. So what they did was they tested in production, right? They had known test cases. So the ENIAC was all about doing math, basically. They had known formulas with known results that they would feed to this machine and see if the result they got out was correct. they had monitoring, physical monitoring wired into the machine, like that actual sort of, gauges and other things wired into the machine to see that the vacuum tubes are doing what they needed to do. They had something called marginal checking, which is, you can see as a sort of fuzzing or chaos engineering, where they purposely put voltages on the vacuum tubes that were just out of spec on purpose to see that they wouldn't break, essentially, and they wouldn't have to replace them in the middle of doing calculations. So the first computer that ever existed only had production. Where do we go wrong? Why do we have all these environments, right? Why don't we just go back to our roots and do computing the way it was meant to be done? Because non-production environments, I argue, are a costly hoax, right? So costly, I only got into convince you guys that non-production is costly. I am reliably informed by LLMs that 20 to 50% of IT expenditure is on non-production environments. It's hard to kind of, Gartner doesn't really do reports about like non-production costs extra, because it's also kind of hard to pin down. But and you guys know this from, I guess, your own practice in IT, that there are a large percentage of the IT costs are non-production environments. So they cost money to acquire, but they also cost money to operate, right? I know this from a very personal experience where I was at the company I worked. I was on the on-call team, and most of the pages I got, most of the work I had to do was fixing the ELK stack in the acceptance environment when someone was doing a load test. Right? So it costs money to acquire these resources. It costs money to operate these resources. There's huge potential for waste, right? Resources that can be disabled but often aren't, in acceptance and tests, stuff that can be turned off during non-working hours. It takes time to set that up correctly. It takes effort to make sure that you're actually saving the money you should be saving. Unnecessary duplications, where I work at the moment. So I work at Jumbo for Skyworks. We have a Kubernetes cluster for every environment. So we have dev, acceptance, test, and production Kubernetes cluster. That's 4 times a control plane. That could be just 1, right? And then you have developers who just, or whoever, who just deploy stuff in development, deploy stuff in test just to try stuff out, forget about it, and then a year later you realize you've been running an EKS cluster to the tune of about $1,200 per month for the past year, right? Tons of potential for waste, for overspending. They say that there's a saying about AWS that AWS underwrites a war on Walmart. Do you guys know the saying? No. Okay. So the idea is that AWS actually makes all the money, which keeps Amazon.com cheap, so they can actually compete with Walmart and the other retailers. But I think it's not actually AWS; it's the resources you guys forgot to turn off that's underwriting that war on Walmart. And deploying to dev, tests, and acceptance takes time and coordination, right? You have to actually, know what you're doing on these environments. You have to actually coordinate it. What version is running where? What do you do when you have production hotfixes that, skip the entire pipeline? You have to backport. It's all, a huge hassle, basically. So, costly, yes? I think we can all agree. So, non-prod is a hoax. This is something I've been saying for a very long time, and honestly, I just enjoy saying the word hoax, so I like this catchphrase. No matter how hard you try, non-production will never actually match production, right? The data is different. So I did a trial run of this presentation last week at the Skyworks office, and one of my colleagues said, yeah, you say the data is different. Actually, it isn't, because every 2 weeks or every month we do a full snapshot of production data and put it in test. First of all, if you do that without anonymizing the user data, you have a problem. You just don't know it. If you do anonymize the user data, at a company I used to work for, we actually had bugs in test, broken test cases that were down to the fact that we were anonymizing the data in a way that the test cases couldn't handle. So that, even if you have exact production data in acceptance and tests, then you might have AVG issues. And if you do all kinds of anonymizing and stuff, that also leads to its own class of problems. So the load is different. I think that's pretty obvious. Even if you are any serious scale, reproducing that scale via load testing is possible, but it's a lot of work. It probably costs a lot of money, and the question is if it's actually doable or not. The scale is different. You can say, my acceptance environment is exactly the same as production environment, but is it really? And the stakes are different. That's the big one. People deploying to acceptance just don't feel the same fear of God, for lack of a better term, that they do when they deploy to production, right? The stakes are just different. And on the one hand, that seems like it's nice because it lowers the barrier to deployment, but on the other hand, it also lowers the barrier to deploying all kinds of crap that you would never dream of deploying to production. So the question is, and the question you have to ask yourself is, as a model for production, how useful are these environments really? Then there's people who say, well, yeah, you can say, get rid of the test environment, but I don't want to test in production. Well, guess what? You do. You just don't call it that. But unless you can prove to me that the code you deploy to production is bug-free and will not have any unintended side effects, you are testing in production. You just don't call it that, but you are, right? It's just the way that IT works, or the way that development works. And then finally, we need to do integration tests. Like, yeah. We can't just push to production because there might be weird things that happen. We need to test that first in an integration test environment. Fine. But given enough microservices, given enough deployments, you're not really testing anything beyond your ability to actually get something up and running in that integration environment. You're not actually testing the integration properly. And while knowing that something will actually spin up and start working is valuable, the actual integration is what you care about. And you're not testing it. And why? Well, let me show you. Your integration environment is either a fraud or a huge impediment. Forgive these graphics there. They're 10 years old from my old presentation, but I haven't been able to come up with anything better. Sorry. So you have you have a bunch of teams, 4 teams, and let's say that we work in a company where they're on a 4-week cycle. So you have version 1 in production, version 2 in, let's say, acceptance, and version 3 in test. And so how does the cycle work? Well, 4 weeks later, you have this, version 2, everything moves along nicely. And then 4 weeks later, you have the new version and test, and then everything moves along at a regular pace. Fine, no problem. So what is integration testing? Right? What are you testing when you test in your integration environment? Well, you're supposed to test a known combination of services and applications for a certain period of time. Right? That's the point. If you don't do that, then actually, what are you doing? If you're not testing a known combination of software for a certain period of time and running tests against something that you know to be a certain configuration that you know, or that you are aware of, then actually what is it that you're testing, right? Let's change the rhythm at which the teams deploy software. So now the first team is still on 4 weeks, the second team is on 4 days, the third team has adopted the Mayan calendar. Might be a team in Guatemala, I don't know. And the last team is just deploying whenever their features are ready, right? So now what happens is the versions don't line up anymore, right? So teams are deploying at different rates. Maybe you're doing continuous deployment. Anyway, the versions in the different environments no longer progress at the same cadence. So now do you want to do an integration test? Well, you need to have a fixed configuration, right? If you don't have a fixed configuration, if things are constantly changing, services are constantly being deployed while you're doing the integration test, you're not really testing anything, right? You might be testing thing 1 that someone deploys, and now you're testing a different configuration. Your tests have now become pointless because you don't know what you're testing anymore. So what do? Well, you fix the versions, right? Which is fine as long as everyone's on the same cadence. But if you fix the version for those doing 4-week releases, then everyone else is suddenly blocked. Does that make sense? So what is the point of integration testing if anything can change at any time, right? You have this choice between, we go back to my statement. You have this choice between either doing integration tests even though you don't know what you're testing, or you have to stop whatever it is you're doing for the amount of time you're running that test. Either it's a huge impediment to velocity, or you don't know what you're testing. So what's the answer to this predicament? Well, my answer would be all you need is production, right? Just focus on production, right? It's the most production-like environment you have, so it's great for testing, right? You can liberate yourself from the cost and overhead of managing the other environments. So there's no need to manage the other environments. All the headache that comes along with it, it's gone. And you can drastically reduce your code inventory, right? I don't know if you guys are familiar with the concept of code inventory, but I always find it illuminating, so to speak, to think about as long as your code is in acceptance, development, or testing, it's not making any money, right? It's not out there producing revenue. It's like it's on the shelf. The same way that if a retailer buys 100 of something and can only display 5 in their shop, they have 95 things sitting on a shelf somewhere not making them money. If you only have production, there's none of this code inventory, right? All the code that gets deployed is immediately generating revenue. So what's the road to enlightenment, right? So anyone who is already working like this with just production, please raise their hand. Yeah? Is that true, Abu? So most people are not in this situation. So how do we get there, right? How do we get to a point where we have just production and nothing else? Well, first of all, you have to start with kind of the basics of software development as it is in 2025, which is rock solid per service continuous integration and testing, right? Shift everything left that you can possibly shift left. Do everything in terms of integration testing as well. Do it in isolation, and do it in a way that is automated, just modern software engineering practices. Advanced deployment strategies, right? If you don't want to take a chance on, updating some software for all your users at the same time because you're afraid of what might happen, do canary releases, do blue-green releases, there's all kinds of advanced deployment techniques that you can use which are available and have been used for a long time that you can employ to mitigate the risks of deploying something to production. And by the way, all this stuff is a good idea anyway, right? All this stuff is something you should be doing full stop, regardless of whether just do production or not. Feature flags, another big one, right? Turn stuff on after the code has been deployed to production, as opposed to turning it on when you deploy the code to production. Robust software development, right? Chaos engineering, graceful degradation. Nothing I'm saying here is groundbreaking at all. It's just a matter of, and also stop reinventing the wheel. There's tons of organizations which, as we speak, are all coding their own GitHub actions for stuff that is already solved by tons of other tools. Don't do that, right? Look at mature platforms, mature tooling that is available, and don't try and invent the wheel yourself. And then finally, the step-by-step approach to prod only, which is, I would argue, is just get rid of the environments one by one. Start by getting rid of your development environments. So if anyone here can honestly sort of motivate a development environment as separate from a test environment, I don't have any stickers to give out, but I will give you a Skyworks sticker because honestly, I don't know. The development environment is just for developers to basically dig around in, right? That's all it is. Get rid of it. Then get rid of the test. Get rid of the test environment. Get rid of the acceptance environment, and finally you're left for only production. And do serious observability, right? Know what your software is doing in production. If you don't have this, if you don't have serious observability, you will end up like this. You'll end up at the top of a mountain, you'll have done all the work, you're there, but you don't know what the hell is going on because you can't see anything, right? Have serious observability. Otherwise, you don't know what your software is doing in production. That's basically not acceptable, right? You're relying on your customers or your clients or whoever to tell you when there's an issue. Not acceptable. removing DTA, so removing non-prod, I think makes a lot of financial sense, right? So you probably all have a lot of questions. Let me preempt some of those. Should everyone have just production? No, probably not, right? I don't know if you guys were here for the talk about the Apollo mission earlier, but if you're developing satellites and round-trip communication takes 2 days and canary releases aren't really a thing, then maybe it's a good idea to have a test environment, right? So no, this is not for everything. This is basically aimed at, or my talk is mostly aimed at, enterprises that have a microservice architecture where you have, tons of changes going on and this modern tooling available to you, right? Is this a silver bullet? Well, no, I'm not going to tell you that if you, ditch your, if you ditch your non-prod environments, everything will go well. You have to actually do the work, but also it's a trade-off, right? Yes, if you do this, you will get more errors in production, maybe, right? But at the same time, you have to consider what it costs, right? Let's say you have, 12% more errors in production as opposed to if you had a testing environment and, all the other environments. Well, what does that cost, right? And is that cost offset by the fact that you no longer have to maintain these other environments and the fact that you don't have this overhead of doing all this other stuff, right? It's a trade-off. And by the way, so lots of people say, yeah, I had a manager at a previous company that I worked at, and it's like, do you know how many errors we find in test? We can't just get rid of tests. Well, yeah, yes, but also if you have these processes that find these errors earlier outside of the environment, then you can actually mitigate those risks. And also, despite the fact that you have all these environments, you're still finding errors in production anyway, right? Your production is not bug-free by any means. And then, so one of my colleagues said last week, yeah, this is great, but what if my teammates are really immature? And I don't mean immature like they make fart jokes, but I mean like they well, yeah. I mean, they are not, shall we say, up to speed with modern software engineering practices. So then the answer is, like with any technology, do incremental adoption, right? Build a solid foundation, observability, CI, et cetera, use the right tools, and finally, it's a change of mindset. It's like with anything. It's like with, adopting DevOps, adopting test-driven development. It's a change of mindset. Yes, your team may be immature. Yes, you may feel like your team may not be able to handle this right now, but that's true for a lot of things, and a lot of things are, DevOps is also something that lots of people said, well, my teams can't handle that. But guess what? If you just keep at it, then things will eventually be adopted. Yeah. So for every problem you face, I want you guys, so the next time you have this, you want to try something new with, whatever it is that you're doing at work, try and think to yourself, how can I do this in production and just production, right? Do it like as a sort of mental exercise. Try and consider, if I want to roll out this change, if I want to do it in production only, and I want to do it safely, how would that work? Just as a kind of mental exercise to prepare your mind for enlightenment, shall we say. Thank you very much.